Tēnā koutou aku tawera. In this video lesson, we are going to be introducing the normal distribution. So let's have a look at this example. We've got a histogram that shows the height of 1,000 garden gnomes. And we're always going to have on the x-axis a scale, and it's going to be, in this case, measuring the height. And as we go up the y-axis, that's going to be showing how many there are, or in other words, the frequency. Now, one thing about the normal distribution, they're going to have some distinct features, and these are worth remembering. Please put these in your notes. If we have something that is a normal distribution, it's going to be symmetrical. In other words, there's going to be a middle left side, looks pretty much just like the right side. We're going to also notice that most of the data is in the center of the graph, and they taper away as you go off to the right on the far side and off to the left. Okay, so many real-life situations can be modeled using a normal distribution, and since the data is continuous, meaning things that were measured with a ruler or timed with a stopwatch, not counted up, the probabilities are found at an interval, not a single point. So below is an example of the normal curve and the shape of a normal distribution. You're going to practice drawing these, and don't be frustrated the first few times you draw them. They don't come out right. The more you practice drawing them, the better they're going to get, okay? So some of the common features, as I said, and please put these in your notes. The shape is symmetrical with the mean in the middle. The shape is often described as bell-shaped. There is a single mode, meaning the mode is singular, and that mode is also in the middle. And when we've got a purely normal distribution, the mode is the same as the mean, which is the same as the median. And it also bears repeating that most of the data is in the middle with a small percentage at either end. So we're not saying it's impossible to be out there at the end. It's just a lot less likely. If you were to choose a value at random, it's more likely to be closer to the mean. Okay? Next, a normal distribution is defined by two parameters or two measurements, and these are known as the mean with the Greek letter mu and the standard deviation, Greek letter sigma. Most events, as I said, lie close to the mean, with very few far from the mean. Now, just like we call the range a measure of spread in statistics, there's a special word for that. The standard deviation is also a measure of spread. And the standard deviation gives us a way to measure the probability of an event lying in a certain range. In other words, the standard deviation, which is sigma, is a way to describe how far away from the mean are we. Okay, so the standard deviation, as I said, is the Greek letter sigma. And there are 1, 2, 3 standard deviations on the right side of the mean. And we can see here the mean mu minus 1 standard deviation. Here is this one, mu minus 2 standard deviations, and mu minus 3 standard deviations. So there are, within 1 standard deviation below and above the mean, 34.1 times 2 is 68.2. If you were to add 34.1 plus 13.6 times 2, 95.4% of values lie within 2 standard deviations of the mean, and 99.7% of all the values lie within 3 standard deviations of the mean. Okay, so again, it's not impossible to be beyond that 3rd standard deviation. It's just extremely unlikely. Okay, please add this to your notes. You want to have this committed to memory, that saying that the probability of being within 1 standard deviation above the mean is 34.1%. The probability of being 1 standard deviation below the mean is 34.1%. Okay, please add these to your notes. I'll be right back with part 2 of this video.